Yeah. So just make this one has the starting phase for 5 minutes. I will speak. Then you can go from the beginning, sir.
Okay, now I have 5 minutes with me.
No, sir. After 3 minutes, okay. Let's introduce. Sorry. Let's start everyone to come.
Okay, you do that, but give me 3 minutes to join. Okay.
Okay. Okay.
Okay,
No
sir.
problem. Sir. We will allow the students, sir. Okay. Allow everyone.
Okay, we are already on YouTube Live.
Yeah. 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 Yeah.
Okay, I'm admitting all.
Yeah. Admitting all. Admitting all.
Yeah, YouTube Live is on also.
Yeah. Yeah. I saw. Just share with everyone.
Okay, let's unmute everyone. Let's mute everyone.
Yeah. Let's mute everyone and allow everyone. Put in
Okay,
status
we're
also.
already on YouTube Live. Nikhil.
Yeah.
लेकिन मेरा हॉटस्पॉट को बचा के रखती है ना।
तुम्हारा डालो, मेरा अच्छा नहीं है। मेरा डालो। Did you watch a video full day? नहीं बड़ी शुरू हो जाएगा।
Yeah. Sir came. Yeah. A very good evening to everyone. We, the team of Petroleum Engineers Association, is delighted to organize Workshop 1.0 Get Ready to Fly with Us on the theme Well Controlled Technology in Oil and Gas Industry. We are very pleased to introduce Vipin Kumar Bhalla sir, who will be our speaker for today's session, who has rich experience in oil and gas industry. Mr. Vipin Kumar Bhalla sir is a drilling and well control instructor. He has worked in ONGC for 24 years. Then he worked for KOC Kuwait Oil Company, ADCO Abu Dhabi Company for Onshore Petroleum Operations Ltd, which is now a part of ADNOC, Abu Dhabi National Oil Company. And then he joined PDO Oman as a drilling supervisor. Later, he has joined in a Denmark-based company as a trainer to drilling engineers at different places in Asia, Europe, and Trinidad. We will also be posting the video on our YouTube channel, so you can access in anytime. And also, we are going YouTube live. Now, I would like Vipin Kumar Bhalla sir to start the session by sharing their knowledge on well-controlled technology in oil and gas industry. Thank you.
Hello. Hello.
Sir.
Yeah, can you hear me?
Yes, sir. Yes, sir.
Okay, so I thank
Sir, your
Petroleum
screen is not coming,
Association.
sir. Just
My screen should be coming. Is it coming now?
no, sir.
1 minute.
Yes, sir. No problem.
Now coming.
Uh, sir, go to screen share option. You will get, sir.
Are you getting my PPT?
No, sir. Sir, your mic is mute. No, sir. Your
Nikhil, I can hear you, but
sir, open your share screen, sir. Go to share screen option, sir.
okay, 1 minute.
Yeah, sir. You can take, sir. We will start at 6:10, sir.
Okay, no problem. So, are you getting my face, my video?
No, sir. Yes, sir. Your video is coming, sir, but your screen is not coming, sir. Share screen option.
Okay. That means in my PPT, right?
Yeah, go to PPT option, sir.
Okay. Now I'm in PPT and I am opening it fully. Okay.
Okay. Yeah, sir. Okay.
And let me share screen. शेयर स्क्रीन कैसे आएगा? Okay.
Sir, at the bottom, I told, no, sir, screen share.
Bottom left or bottom right? Bottom left or bottom right?
Sir, click on share button, sir.
Okay, but where is share button?
Sir, on Zoom app, once you go and go to share screen option, sir.
One minute, 1 minute. 1 minute. Okay, I am in the share. You cannot start screen share while the other participants is sharing.
Please. 1 second, sir. 1 second. Yeah, now start, sir.
Now, can you see me? Can you see my video? Okay.
Sir, go to Zoom app. At the bottom, you will find the share screen option. Just from there, start, sir.
In the bottom, there is leave. Where is share?
Sir, go to Zoom app. I told you, sir, go to Zoom app, sir.
Okay. 1 minute. Okay. Okay. Share screen.
Yeah, share screen, sir.
Now okay.
1 second, sir.
No, sir.
Okay. 1 minute. Now okay. Now
Yeah,
okay.
yeah. Now it's start. It will start.
Yes, sir. Yes, sir. Yes, sir. Go to first slide.
No.
Yeah. So maximize it, sir.
Okay. Okay. All right.
Yeah.
All right.
Yes, sir. So just maximize it, sir. Once, so that
I have maximized.
yeah. No problem. Yeah. You can start, sir.
Okay. So thank you very much for giving to the association, and also thankful to all the participants who are participating in this program for giving me this opportunity. I am excited about it, and we hope it will be a very successful evening of 2 hours or a little more than that. Topic is and how important is well control technology. You can understand from incidents which has happened, like the one recently there now in the Bag area. So there is the village is there, they are vacated, the fighters have died, the environment is polluted, and it has
Sir, what happened, sir? Sir, your screen is not coming, sir, again, sir. Guys, sorry for inconvenience. Sir is facing some net problem, so just please wait for 5 to 10 minutes. Yeah, wait, sir is coming just in 5 minutes. Don't worry. Yeah, sir is joining. Yeah, sir, it came. Yeah, sir came. Don't worry. Now, sir will start.
Hello, can you hear me now?
Yes, sir. Yes, sir. Sir, open your screen, sir.
I'll do that. Okay.
Yeah.
Yeah, can you see the screen now?
Yes, sir. We can see, sir.
Okay. So can participants see me now?
So just maximize it, sir, and you can start, sir. No problem.
Yeah. Can everybody can hear me now?
Yeah, yeah, sir.
Yeah, okay. I really apologize to all the participants, particularly I see I am on a hill and internet is very poor here. So I have to reuse some other source of internet and to be in touch with you. So I really apologize for this inconvenience which has happened. And now I hope it will go smooth. And we'll be talking for another 2 hours from here now. And that's 2 hours we will deal with all the well control objectives and well control procedures and how actually a drilling engineer does the well control. And I promise you, by the end of the program, after 2 hours and 15 minutes, you will find that you will be able to sense very clearly how a drilling engineer actually kills the well. It will be something doable, something tangible, something understandable. So that is what our intent of the program is. This is actually a 3 to 5 days program. So I have just condensed it to 2 hours, and I am trying so that in these 2 hours, I should be able to give you a very clear idea about what well control is. Okay, Nikhil, am my voice coming rightly and every
Yeah,
participant getting it?
yeah, absolutely, sir. Absolutely fine, sir.
Yeah, okay. So in this program of well control, we will be talking, and how important well control I was telling you is, like you have seen many incidents in offshore, on onshore, at different places. In India also, in the south of India, there was an incident around 10 years back, and now there is an incident in Assam with Oil India in Tinsukia, where there is a fire and there is a lot of hazards, and we need, that is why there is a need for everybody, whether he's a drilling engineer or a reservoir engineer or he's a production engineer or he's a geologist or anybody, he must know a little about well control so that you can at least appreciate what is going on and how much impactful it can be to the drilling companies, how much impactful it can be to the people who live nearby, how much impactful it can be to the governments, how much impactful it can be economically also. So that is why it is a very important subject, and I wish you will give all your attention to it so that we can know what exactly it is. Okay, so starting with the basics of the well control, we will be talking about first the introductory part of the well control, how what well control is and how it happens, and also we will see how what are the causes which the kick or blowout, why they happen, and then how we can prevent them, what are their warning signs, and what are the equipments which we have which we can use to control well control situations, and how to use them effectively, and how the people should be trained enough so that they do the right actions at the right time so that well controlled situation doesn't lead from a kick to a blowout. That is what our intention is. And the last part of the program will be the operation of killing of a well, like how exactly a drilling engineer goes for it, like what he does, what type of calculations he does, what type of teamwork is required, how different people in the team club together to do the operation of well control and execute that. So we will discuss all that, and that will be our program today. I hope you will enjoy and it will add to your knowledge. Thank you. So next slide is well control objective. So our well control is that when we drill deep down in the earth strata, we experience a high formation pressures reservoirs. And our job is to maintain the pressures in the well so that those reservoir fluids don't come inside the well bore and doesn't create any complication for ourselves. If such reservoir fluids come into the well bore, it can complicate and drilling become impossible. So that entry of the formation fluids into the well should be prohibited at all costs. And if it comes, then we have procedures how to mitigate that, how to control that, to avoid any blowout situation like the one we have in Assam now. So that is our objective. Before I go into the well control in detail, let us talk about well barriers. Why I am talking about well barriers in the beginning? Because if you see this particular case in Assam, what they were doing, actually they were doing a well intervention job. I just say much of you may not understand, but just listen to what I am saying. And by the end of the program today, you will see that you will be able to appreciate a lot what exactly is happening there. Okay, so what was happening there was that they had one zone active and they had BOP and wellhead installed on the well, right? And they wanted to shift from that particular object production from that particular target to some other object of interest, right? So what they did was they put a cement plug on the object which they don't want, from where they don't want the production. They put a cement plug there, and they had brine of the right brine weight in the well. So according to them, they had brine in the well and they have a cement plug, so they can go, and they wanted to do some repair work in the wellhead. I don't know why, much of data is not available. So anyway, they wanted to do some repair work in the wellhead, and for that they need to remove the BOP, and the well was exposed, and finally that cement plug failed or whatever happened, and there was bubbles coming out which later got fire, and this is the incident. Now, what is a barrier? Why BOP is a barrier which they removed? Okay, why BOP is a barrier? Because BOP is equipment, okay, but it doesn't become a barrier only by being equipment, well control equipment. No, it need to be tested. Okay, a tested BOP is a barrier. Similarly, a cement plug, if tested, is a barrier. If not tested, you don't know what is down in the earth. What is happening there? You don't know that. Until tested, it is not a barrier. That is one thing to be very careful about. Okay, so that is why I am talking about well barriers. In well barriers, when we close a BOP, suppose we are drilling and we got an influx in the well, formation fluids finally suppose entered in the well, and we close the BOP. When we close a BOP, not only BOP, but the casing, the wellhead, the drill pipe, and the cement behind the casing, all of them are under pressure. Not only BOP, wellhead is under pressure, casing is under pressure, the formation below the casing is under pressure, the cement behind the casing will also be exposed to the pressure. So all of them are acting together, not only BOP. So BOP is one thing, and casing is another thing, wellhead, cement behind the casing, all of them together do the job. All of them need to be intact, like casing need to be tested at certain pressure, so that the pressure which will be imposed when the kick comes, it should be able to sustain that. Wellhead seals and wellhead should have the right capacity, so that when the pressures will come, wellhead should be able to take that pressure. Similarly, the cement behind the casing should be intact, and CBR and other logs should be done, so that when the kick comes, that cement should not fail under the pressure of that kick. So all these together need to be having a integrity. So this is well bore integrity, and these barrier elements together is called the well bore envelope. These elements together, these are the different elements like fluid, drilling fluid is okay. So these all elements like BOP, tubulars, rams, wellhead, cement, safety valve, all these equipment together are facing those pressures, and they should have their integrity of their own. They should be of the right capacity, of the right rating, so that they can deal with the kick situation. This is the integrity of the well barriers. Okay, so this is little about well barriers, which we should all know. So my next slide is different elements, like in the photograph here, you have seen BOP, RAM, wellhead, cement. So similarly, these all are elements of the barrier elements, which together, like wellhead, drill string, packers or safety walls, completion string or tubing hanger, all of them are elements, and they together are facing the pressures which are generated by the kick, and they should all have that integrity to handle the kick effectively. So this all together becomes the barrier envelope, and this total envelope should have the right integrity to handle the kick effectively. So this is the barrier concept in short, which I think I should have before I start the well control course, because this is very important. And if the barrier and furthermore, if the barrier, it is not a barrier. This is what happens at many occasions. So that's why I felt I must share that. Further and start our program. So when we are drilling a formation, and as we drill further, we can encounter, particularly in the exploratory wells, we may come across very high pressure zones, right? Now, when we are drilling, how will we encounter such high pressures? What will we do? Who will stop them? What stops them is the mud. Other than doing the primary functions of taking the cuttings out of the well and cooling the bait and lubricating the bait and suspending the cutting when circulation is not, or giving a corrosion resistance and all that. These are all the work which the mud does. But also, very importantly, mud acts as a primary barrier. Now, this mud, because of its hydrostatic head, doesn't allow the high pressures from the formations to come into the well. But this mud should be of the right mud weight. That is the point. So when you see, when we drill a well, from our graphs, from our pore pressure values, we should select the right mud weight so that we can effectively drill that well. If the mud weight hydrostatic pressure in the well is more than the formation pressure, we are over balance, and that is what we should be. Our mud hydrostatic pressure should be more than the formation pressures, so that the hydrostatic pressure of the mud can control formation fluid to come in. This is an overbalance condition, and this is a wanted condition. It should be like that. Okay, but for some reason, if the mud hydrostatic pressure at the bottom become less than the formation pressure, you will get a kick. That is what happens. So a good drilling engineer will not allow his mud hydrostatic pressure at the bottom to fall below the formation pressure. Okay, and if it falls, then you will get a kick. Okay, once you have got a kick, suppose you have entered a high pressure zone. Suppose your prediction was that you are using, say, 15.8 ppg mud, right? That is what you anticipated. But suddenly you have come into a very, very high pressure, unexpected zone, which demands a much more higher mud weight, which you were not anticipating. So naturally, some kick will come into the well. Now, if the kick has come into the well, your next action will be to shut in the BOP. Okay, so now this BOP which you will shut in when the kick comes is your secondary well control. Primary was mud, which was handling everything. Somehow mud failed. Maybe the high pressure encountered you were not anticipating, and your mud weight was less than required, and formation fluids started entering the wellbore. Now formation fluids are entering the wellbore. Well is flowing. The action you should take, people should be trained to take, is to close the BOP in as less time as possible. And after the closure of the BOP, your BOP becomes the secondary well control equipment acting on the well. So first is when influx enters the well, it is called a kick, and then you close the BOP and your secondary well control equipment called BOP comes into action and the well is stabilized. But if the BOP fails for some reason, or some reason BOP is not there or not functional or anything, then there can be a blowout. And if there is a blowout, then you have to have tertiary means of controlling the well. If there is a blowout, then you may have to cap it. What they may be trying in the Assam to cap it, first to extinguish the fire, and then using cranes and other equipments to cap that well effectively. And if capping works, then they later, if it doesn't work or whatever, then they may have to go for some relief well or something like some other advanced type of relief wells and capping process and extinguishing of the fire. All this comes under tertiary well control, which we will not doing much into. Okay, so coming to our next slide. So if the formation fluid enters our borehole, that is a kick, and a drilling engineer, when drilling, should use the right mud weight not to allow the kick entry into the well. And if the kick enters and you have to use your secondary means like BOP that will hold the kick, and if everything fails, then you can have a difficult situation like blowout, which anybody should avoid. And people are trained on the rigs not to allow these things to happen. Now, a drilling engineer wants to drill overbalance. He wants his mud weight hydrostatic head to be more than the formation pressure. That's what he wants. But sometimes he goes under balance. Why he goes under balance? One of the reasons why he goes under balance is that he gets the formation of a little more or much more pressurized formation. That may be one of the reasons why he gets under balance. Second reason why he may get under balance is the mud weight which he may be using may not be correct. Like there may be some measurement issue, or he might have pumped some pill, some liquid which may be having a lesser mud weight, or for some reason the hydrostatic mud weight is reduced for some reason or other. I'll tell you more when I go further how reduction of the hydrostatic pressure can happen. I'll come to that. There is a slide for that. Now, in the formation, there can be normal pressure, abnormal pressure, or subnormal pressure. The formations have these three types of pressures. It is normal pressure if the gradient of the formation pressure, if the formation pressure gradient means every foot, if it is increasing 0.433 to 0.465 psi every foot, then it is normal. This is actually a saline water gradient. Generally, in the reservoir, in the earth strata, there are porous spaces, and those pores are filled with saline water. And the pressure, the normal pressure in the normal circumstances, the pressure in the formation is because of the hydrostatic head of the saline water which is there in the pores in the formation, right? So that is a normal case, right? But sometimes there is an abnormality because of some geological reasons that you have pressures and pressure gradients in the formation more than 0.465 psi per foot, then you will call it abnormal, because this is not merely the hydrostatic of the saline water in the formation fluid, but something more. So it is little more. So there is some abnormality somewhere. We will see what are these abnormalities and how it happens. So there is a little abnormality. So any formation pressure gradient, if it is more than 0.465 psi per foot, it is called, for technical sake, abnormal pressure range. And if for some reason it is less than 0.433, then it is called subnormal pressured formation, right? Normal is when there is saline water in the formation pores, and that saline water in the pores of the formation is putting some weight, hydrostatic weight, pressure, and that pressure becomes the formation pressure. If that is the case, it is a normal one. If some geological thing makes it more than that, so little more means abnormal. And if it is less for some reason or other, it is subnormal. Why it becomes subnormal? Because there may be a formation which may have at some time very good pressure, but once you have taken many wells and exploited that formation, and there are many wells on production, and slowly that pressure depletes, and finally when you drill further wells in that area, you will find that the pressure in that particular formation, because of a lot of wells had been drilled there, become subnormal also, right? Nikhil, is my voice and everything going okay, and everybody getting, is it okay, going good? Okay, very good. So this is about abnormal pressure, normal pressure, and subnormal pressure. Now, why abnormal pressures occur? Why in the formations there are abnormal pressure? And as I told you, abnormal pressure is when the formation pressure is not merely the saline water hydrostatic head, but much more than that, because of certain geological reasons. And let us see, explore into what are those reasons. Okay, so when the sedimentation, geologically looking, when the sedimentation occurs, there are new layers of sediments. They get gathered about one after the another, and there are more and more in the delta of a river or whatever. Different sedimentation layers are getting accumulated, and those sedimented layers put a weight on the last layers which were there, like the one layer, and there are many layers above that. So the layers above that, they will put some weight on the layer which is below, right? So when that overburden pressure of the layers above, they will be exerted on the layer below, then the fluid there also will get that overburden pressure. But mostly that fluid will get a chance to escape. And if it gets a chance to escape, then formation fluid at the lower level where the overburden is acting, that will be at a normal pressure because it got a chance to escape, and finally it will be only the saline water. But sometimes because of some impermeability developed, that pressured fluid which is taking the overburden of the top many layers, that lower layer, and the fluid around there in the lower layer, which is getting the overburden of the top layers, that fluid will be under pressure because of that overburden of the upper layers, that if it doesn't get a chance to escape because of some impermeability, develops a high pressure. This is one of the most important reasons for the abnormal pressures to occur in the oil industry. 99% of the abnormal pressure zones are because of this. And when that high pressure is locked there, and that fluid at the bottom has taken most of the overburden which is of the above layer, then naturally the matrix part will get less share of the overburden, and it will be under compacted. So see, now I don't have whiteboard facility very easy here. So this is one of the most important reasons that that fluid pressure at the bottom not getting a chance to escape and develop a high pressure. So this is one of the main reasons 90% of the wells have this reason as the high pressure zones. Then there is the Artesian effect. In the Artesian effect, actually the formation may be starting its linkage from some lake on the hill at a height. So there may be some lake which may be source, and it may have a link from there from the height of the hill, and you are drilling in the valley, correct? So when you are drilling, suppose you have drilled 3000 meters, the formation has started from the top of the hill and it has followed down 5000 feet, correct? So the pressure in the formation will be according to the 5000 depth which is starting from the hill, and you are in the valley, and according to you the depth is only 3000. That is why, that is one of the reasons you may find that you may have to use a little higher mud weight, and the pressure will not be a little higher than that 3000, what it should be at 3000, which is for you from the valley. From the valley, depth of the well is 3000. So you should expect at 3000 certain pressure. But the pressure is coming to the formation from a hill which is 5000. So it can be called a little abnormal, little more than expected pressure. So this is called Artesian effect. I'm sorry, I cannot show you a diagram. If I would have shown a diagram, that would have become more clearer to you. But anyway, this is very preliminary things. Our main job is to see how a drilling engineers actually kill the well, and that is what I'll give more attention on. And so I'll pass by this a little more quickly. So another thing is, when there is a gas cap, then also sometimes you encountered at the top of the gas cap high pressures, abnormal pressures, and sometimes there is a poor cementation in the offset wells, and the lower zones from the offset well, they may get a communication to the top layers through the bad cementation of that particular well. So that is how the formations below in the offset well, they get a communication with the upper formation through the bad cementation, and the new well which you are drilling may get a higher pressure than expected. And these are the few reasons why abnormal pressures are generally happen. I'm sorry there are no diagrams, otherwise it would have been a little more clearer, but don't mind. These are the reasons. Also, then comes subnormal pressure, as I told you, is because if the formation has lost because of overproduction, it becomes depleted, and then it is subnormal pressure. Mud hydrostatic, which we use as a mean to control the formation pressure, can reduce, can be that you may not be controlling the mud weight rightly. Actually, when you drill a well, you should be observing the mud weight where it is being pumped, before the pumping, at the shell shaker, at different points, you see. So that there should not be any mistake, and from time to time there is a monitoring of the well mud weight, and if that monitoring is not proper, you may be pumping less mud weight and may be creating a problem. So right monitoring of the mud weight is very important at different places. That is one of the reasons which may result in the reduced mud weight, and finally reduced hydrostatic pressure, which may cause a kick, right? And also there can be reduced column. How reduced column can be there? Suppose you are drilling and you get a loss somewhere, the formation is very weak and a lot of mud goes into that, so level in the well bore falls, and effective height of the mud column to create the hydrostatic head will become less, and some other zone may kick, right? So if there is a loss in some zone, the fluid will come down, and the net effective height will fall down, and another zone which may be become active, and you may get a kick, right? Because the pressure, hydrostatic pressure of the mud is mud weight multiplied by a constant multiplied by TVD, like the mud column height. So mud weight, okay, you are regulating, but this height will fall if there is a loss. The mud column will fall down, and some other zone may get activated. So we have to take care of all that. You should be monitoring. Very important for drilling engineer and others associating him is monitoring the well. You should understand when the loss is coming. You should follow the different volume parameters, whether there is a loss or any other event happening, to detect it before it can create any problem, so that you can take the right action. This is one of the jobs of drilling engineer and his team to work effectively. Okay, so this is bottom hole pressure. Pressure is 0.052 into mud weight in ppg and TVD in feet. This is oil field units. Okay, the pressure is in psi, hydrostatic pressure at the bottom of the well. Pressure in psi 0.052 is a constant. Mud weight is in ppg and TVD is in feet. So this is what generally most of the companies follow. This is called oil field APA or oil field units. So I'll also follow that. Nikhil, are we going okay? Okay, anything, any feedback you feel you need to give me regarding anything, you can give me. Okay, so I am going further. It's okay?
Yes, sir.
Thank you. If any participant has a question, he can just raise his hand. I think there is a facility to raise the hand also, and Nikhil can notice that, and we will see in between also that somebody some question can be answered while we are going ahead. And in the last, of course, we will have a question answer session, and we'll discuss any question coming from you. But in between also, if suppose anybody have a question, he can raise hand, and Nikhil can note down that raise hand, and he can tell me, and I can discuss that particular thing if somebody has.
Sure, sir. Sure, sir.
So you everybody welcome for that.
Yes, sir.
So now, why a kick happens? We are drilling, we are using mud as a primary well control, mud weight is correct, and drilling is in progress, everything smooth. Driller and drilling engineer and his team is employed in different locations to do their respective jobs, and there is a bit change. The bit is wore, and the driller need to pull out the bit, right? So when he pull out, he will, when the string is pulled out, suppose he does it fast, there is something called swabbing happens. If the bit is a little balled up with the mud, and it's a little swelled with some cuttings, and he pushes it up very fast, it will act like a piston, and there will be a swabbing effect, and the pressure below the bit will fall, because like a syringe, like a piston, the whole string, when he'll try to pull it up, it will create a suction effect below the bed, and there will be swabbing effect, and the formation fluids will can come in, and there will be a kick. So that is how swabbing creates a kick. Or you may be having some gas in the well, and you are circulating, and those gas bubbles, when they come up in the surface, they becomes bigger, and that may create an underbalance, and your well may start kicking. Or there is some gas bubble which you have pulled when you were swabbing. You might have swabbed, and then you wanted to go down. So swabbing might not have caused, suppose, the cake. It was not that much to cause a cake, but when you run into that bubble, that will come across the bit and the drill pipe, and it will carry a bigger height. That bubble which was lying at the bottom in the well was, say, 15 feet height, right? But when you run back into the well, then your bit will go down into the bubble, and that bubble will now have not 15 feet but 25 feet height, and that may create a kick. So these are very technical things for the drilling engineer, which he should be careful about. Why I am telling you is that is how a drilling engineer is careful about what he does and what is happening and what monitors are seeing, so that he can avoid the kick. You know how important it is to avoid the kick. Suppose a driller or drilling engineer has pumped a light mud weight. Suppose his bit is balled up and it has collected some cuttings around it, and he want to wash it, and he has pumped some soap solution to wash the bit, but that solution is not as the weight of that mud weight of that particular solution is less than our own mud weight. So that solution can also create a lower total effective mud weight and can create a kick situation. Now, when we are drilling a very high pressure wells, then we need a very high mud weight, and the problem then becomes is that barite, which is used for increasing the mud weight, that barite somehow start settling down. Or if your mud is not very good, the other additives of the muds are not good, and barite from the mud settles down, then the effective hydrostatic of the mud column will reduce, because the mud barite, which is the main element, has settled down. So the effectiveness of the mud will come down, and that may create a problem. So we need to ensure that our mud should be proper in a way that it should be able to hold the barite properly, even when the mud weights are very high for the formations which are having very high pressures, okay, HPST wells or something like that. Then, as I explained to you, there may be a loss circulation situation, that one of the zones may be having loss circulation, and the mud goes into those loss circulation zones, and the level in the borehole will come down, the mud level will come down, and another zone may start kicking, and you may have a kick, right? Another point is when you are pulling out of the hole. Suppose I want to change my bit and I am pulling out of the hole. If I am pulling out of the hole, I should ensure that as I am pulling out the steel pipe out, that level of the mud must be going down, and I should fill the hole in a way so that the steel volume which I am pulling out of the steel pipe which I am taking out, equal amount of mud should be put into the hole. Suppose my pump is not working, that small pump which I am using, or for some reason I am not filling it properly, that can be one of the reasons for kick to occur. So these are different reasons. In spite of the formation pressures not being very high, but the operational reasons which a driller or drilling engineer team need to be on check to ensure that well control situation doesn't occur. Now, how kick can be prevented? Of course, we have talked a great deal about that, that we should be monitoring all the monitors which we have, our, our pumps should be working properly, and mud should be in good condition, and we should keep the hole always full, monitor for any loss circulation zone, and catch that before it catches us. We should note down, we should get that before it creates any problems. So all this type of monitoring should be there. So let us see. If suppose we are drilling an exploratory well. So now in an exploratory well, there are different parameters. In exploratory well, you don't know what the pressure is at the down. It is expected. It is anticipated. There is a data which is provided to you. There are pore pressure data which is there, which may be reliable, which may not be very accurate also. It's a wildcat exploratory well. So in that, you may encounter a very high pressure, and what care a driller must take for such wells to be drilled is this, and what are the warnings which a driller will get from the formation that there may be some difficult situation. So if a driller is drilling and he gets a drilling break, like he is drilling very fast. So if he is drilling very fast, then he should be careful, because as I told you before, under compaction is 90% of the reasons for the high pressure zones in the formation. Under compaction, where the formation fluids have high pressure and the matrix is under compacted, because fluid has taken the pressure. The formation fluid has taken the overburden pressure, and the matrix is under compacted. Now, because it is under compacted, you will get a drilling break and it will drill very fast. So, if you get a drilling break, you should be careful. You should stop the pump, check, and ensure that there is no cake. And if there is no cake, drill further. If there is a cake, close the BOP. And also, there is a you should be careful about your different parameters like torque, drag. This is what the driller will be measuring from his instruments. And if there is a variation in torque and drag, a little more than expected, he should check that his well is okay, stop the pump, check flow, and ensure that there is no cake and everything is fine. If fine, he can go further. If not fine, he can close the BOP. And there is a mud logger unit. That unit is measuring the gas cut in the return flow. Also on the shell checker, there is a man employed who is watching the cuttings, where what size of cuttings are coming, what shape of cuttings is coming. Also, the temperature of the mud is being monitored. The chloride content in the mud is being monitored. The shale which you are getting on the shale checker, the geologist is checking its density and its properties, or some oil show in that. He's monitoring all that. And also, the background gas is being monitored, connection gas or trip gas. There are gas sensors which are measuring. So all these equipments and the team of people, they are on the job in an exploratory well to see, to check which are the warning signs which they may notice and they can avoid a kick. So this is a total team of people: mud locking unit, driller, the derrick man, and many others, drilling engineers, everybody on their toes to see that if well gives a sign, they should catch that sign and to avoid entering into very high pressure zone without the proper preparation. So this is a review of the same thing, the care which the driller need to take to see which are the warning signs which are coming, and to be on his toes to see if there is a kick to handle that. But if there are positive signs, suppose he's drilling and suddenly he's drilling out the well which he have connected, that pit level is increasing, like he's drilling in the loop. Because it is a total loop, the level of the pit should remain same. But he is drilling in the loop and the level should remain same. But suddenly he finds that the pit's level, the liquid level in the pit is increasing. So that is a warning sign for him. Right? That is a positive sign for him that something has gone wrong at the bottom. If he's drilling and the return flow, which should be coming steady, like he's pumping at some rate, and a steady rate should be coming out of the well also. But if he's pumping at say 350 gallons per minute, and return is coming also at the same rate and steady, and suddenly there is an increase in that return rate, that should be a very positive sign that something is going wrong. If all that is going wrong and he can observe that, he should stop the pump and check. And if after stopping the pump, well is still flowing, that means something certainly is wrong down, and well is flowing and formation fluids are entering into the well. This is a positive sign time to close the BOP. So the BOP system is an equipment which will close around the drill pipe or whatever tubular is across them in a very less time, and it has that control system which use minimum time like 30 second or 45 second that BOP will close. And again, once the well was flowing, it was unstable. The primary barrier of the mud was threatened, and once the primary barrier mud is threatened by encountering a high pressure zone, the well flows, it is called kick. And once that encounters, the secondary system should act and come in action, and that is BOP should be closed immediately as soon as possible. Must be in say 2, 3, 4 minutes, and the well should be closed. So our secondary well control system is in operation and well is in stabilized condition. Now I would like to show you some videos so that you can get a clearer sense of Nikhil, can you show the video now?
Yeah, sir.
The blowout preventer, BOP stack, consists of several large valves stacked on top of each other. These large valves are called blowout preventers. Manufacturers rate BOP stacks to work against pressure as low as 2,000 pounds per square inch, or PSI, and as high as 15,000 PSI. About 14,000 kilopascals, over 100,000 kilopascals. Rigs usually have two kinds of preventers. On top is an annular preventer. It's called an annular preventer because it surrounds the top of the well bore in the shape of a ring, or an annulus. Below the annular preventer are ram preventers. The shut-off valves in ram preventers close by forcing or ramming themselves together. The choke line is a line through which well fluids flow to the choke manifold when the preventers are closed. Even though the preventer shut in the well, the crew must have a way to remove or circulate the kick in the mud out of the well. When the BOP shut in the well, mud and formation fluids exit through the choke line to the choke manifold. The manifold is made up of special piping and valves. The most important valve is the choke. The choke is a valve that has an adjustable opening. Crew members circulate the kick through the choke to keep back pressure on the well. Keeping the right amount of back pressure prevents more kick fluids from entering the well. At the same time, they can get the kick and put in heavier mud to kill the well, that is, regain control of it. The well fluids leave the choke manifold and usually go to a mud gas separator. A mud gas separator separates the mud from the gas in the kick. The clean mud goes back to the tanks. The gas is flared or burned a safe distance away. When the well takes a kick and the BOPs are open, well fluids force mud to flow up the well bore and into the BOP stack. When the driller closes the annular BOP, flow stops. Usually, drillers close the annular BOP first. The closed annular BOP diverts the flow of the choke line, which goes to the choke manifold. The driller can open a valve on the choke line and safely circulate the kick out of the well through the choke manifold. Here's an annular preventer. An annular BOP closes on drill pipe, drill collars, or any shape of tubular in the well. It can also close on open hole, a hole with no tubulars in it at all. It's usually the first preventer used to close in the well. Here are 4 types of ram preventers: pipe rams, blind shear rams, and variable bore rams. Pipe rams are used when there is drill pipe in the BOP stack. The pipe rams fit around the pipe, closing off the annulus. Pipe rams back up the annular preventer. That is, in the unlikely event that the annular BOP failed, Crew members could shut the pipe rams to seal the well. Also, some pipe ram preventers are used to hang off or suspend the drill string on subsea BOPs. Blind rams are designed to seal an open hole. If the annular BOP fails and there is no pipe in the hole, the crew could seal the well by closing the blind rams. Blind shear rams are designed with blades that cut through the drill pipe and then seal the open hole. They are used in extreme emergencies, like when an offshore floating rig has to move off a well they're drilling because of a hurricane or other such emergency. Blind shear rams allow them to cut the pipe, seal the hole, and then move the rig a safe distance away. Variable bore rams, or VBR, are special pipe rams that can close over a range of pipe sizes, such as 5-inch diameter to 3-inch diameter.
Okay. Nikhil, they could see the video?
Yeah, it's coming, sir.
Okay. Okay, so video was okay.
Yeah, so video is completed, sir.
All right, so this video explained you how the BOP system is and how the choke manifold system is, how what is the mud gas separator, and how the total system of BOP equipments work, right? Now I will also go a little more in detail. So there can be BOPs of different sizes, depending upon which particular section of the hole you're drilling or which type of well you're drilling. Your BOPs can be very high pressure, say 20,000 psi, or it can be 6,000, 5,000 psi also. So this is called rated working pressure. This is a photograph of an annular BOP, which you have seen in the video also. Annular BOP looks something like that. This is a RAM BOP, and this is the BOP stack. This is very important for you to see. The BOP stack, there are a hydril means annular BOP at the top, and then blind ram, and then there is a spool, and spool means providing an outlet here, and below that there is a pipe ram, and this outlet from the BOP stack goes to choke manifold here, and from the choke manifold then it will go to the mud gas separator, and from there it will go to the shell shaker, etc. So this is a diagram to explain you. So I need not go because I don't have. Okay, so the annular type of preventer has a rubber element which is moved by a piston, which is energized by a hydraulic fluid from a control panel. So there is a BOP control panel which has a high pressured nitrogen cylinders, and they push the fluid to the annular BOP, and once that high pressure fluid enters the annular BOP from the unit, this will activate the BOP. So there is a hydraulic design to activate the annular BOP very fast, So inside the BOP, there is a rubber element and there is a piston, and that piston is actuated by a hydraulic fluid which is connected to a pressurized system. RAM BOP is something like that. There are rams with packing seals of different types, and it can close on a drill pipe. Blind shear ram, if suppose there is no pipe in the well, this blind ram can close on the no pipe in the well, or even if there is a pipe in the well, it can shear, there is a blade there, it can shear the pipe and close the well. If suppose there is a pipe in the well, this blade will shear that pipe, and then finally this blade will go against one tether and it can close also. It can cut and close both the things. So it is called blind shear ram. Ram preventer, there are many ram preventers in a BOP stack. There may be upper pipe ram, 5-inch pipe ram. There may be lower 5-inch pipe ram. There may be variable pipe ram which can close on 5-inch or 3.5-inch drill pipe. There may be a shear ram, or there may be a blind shear ram, the one which I showed you, which can shear and then blind also. Or when you are running a casing, you can put a casing ram. So there are different types of rams there in the BOP stack. In the BOP stack, there is a drilling spool, and this side outlet in the BOP stack, which goes to the choke manifold. So this is the choke manifold. A hose comes from the BOP and comes to this choke manifold. It has many valves and it has 2 or more chokes here, and these chokes can be controlled. The job of the choke is to create a back pressure. When BOP is closed, when we got a kick in the well and BOP is closed, right? Now, our job is that the formation fluids which has come in the well, they should be circulated out actively, right? That is our job, right? So when we circulate those formation fluids which has come into the well, which we don't want, we want to circulate them out of the well, then we will be circulating, and we at that time need to ensure that while circulating, the bottom hole pressure have to use this choke walls, which has a variable range to control and create a restriction so that there is a back pressure created at the choke wall, and that back pressure will act in the well, and with that control we can create a pressure at the bottom equal to the formation pressure, and it is ensured when we are filling the well that well doesn't flow further. So job of the choke is to restrict the flow when we are circulating in a way to create a back pressure, and that back pressure will be added in the pressure of the hydrostatic of the mud, and it will act on the formation pressure and doesn't allow the formation pressure and create a bottom hole pressure more than the formation pressure. So that creating that back pressure, which will create a bottom hole always more than the formation pressure. That is the objective. I'll explain it when I deal with killing of the well. I'll explain it again. That will make more sense. Okay. So this is one of the equipment to be used. BOP control system is system which has many cylinders filled with nitrogen, and it is compressed, and will push some hydraulic fluid which will activate the BOPs in a minimum time. The job of the control system is number 2. There it has 2 main jobs. One is suppose the power supply in the rig goes off and there is a kick in the well. So this BOP control system has pressurized nitrogen, And that energy can be used.
Sir,
That is number one. If there is no
sir, can you please repeat this because the audio was very bad?
audio is bad. Okay. Yeah. Is it okay? Nikhil, audio is okay?
No, sir. Once again, sir, just I think, sir, your mic is not near to you, sir.
All right. Okay. Now audio is okay?
Yeah, yes, sir.
Okay. I'm
Yes, sir.
sorry. So since when it was not okay? Hello, Nikhil. I want to repeat. How much should I repeat?
Sir, choke and manifold, sir.
Okay, choke. All right. So choke manifold has choke there. Okay, choke is equipment which has an arrangement to vary the restriction. It has a restriction in it. In the choke, there is a restriction, and that restriction can be varied using a spindle. Like you can change. You can change the restriction. You can increase the restriction. You can decrease the restriction. Now, if the well, you are circulating the well, and it is being passed, BOP is closed, well is shut in, BOP is closed, and you are circulating with the drilling pumps, and the mud is going inside the drill pipe to the bottom, and outside it is coming in the annulus, and then it is coming to the BOP, and from the BOP it is diverted to the choke manifold. It will come to the choke, and now the fluid is flowing through the choke, and I will control the choke's restriction, and that will create a back pressure there, and that back pressure there will add to the hydrostatic pressure at the bottom, and it will control the bottom hole pressure in the well to be more than the formation pressure. So we are to very methodologically control the choke so that we create enough pressure, back pressure in the choke, so that it can add up and create the bottom hole always while killing the well more than the formation pressure, and doesn't allow any further kick to come in. So it will by regulating it, I will create a pressure in the annular profile in the annulus of the well. I will increase the pressure in the annulus of the well by creating the restricting the flow with the choke, and that will create the bottom hole always can be kept more than the formation pressure. That is the objective. When I do the final procedure of the well control, I'll go again into it, and if not clear now, then it will be clear. Okay, so I'll explain it again when I do that. So a BOP control system is a system which has pressurized nitrogen available in the system. Why this is important? Suppose on the rig power failure is there. Now there is a kick coming in the well, and power failure is there. What to do now? So there should be some system which can get activated even if the power failure is there. So the energy stored in the compressed nitrogen can be used to push the hydraulic fluid into the BOP and close the BOP. This is the main function of the BOP control system. In case of the power failure, it should be able to close the BOP using the compressed nitrogen which it has in the system. Number one. Number two is that this system should be charged enough so that it should close the BOP in a very less time, say in 30 seconds, or if the bigger BOP is there, in 45 seconds. So in such a short time, it should close the BOP. That is the second very important function of BOP control system. So these are the two main functions which BOP control system performs. In subsea BOP system, the BOP is at the seabed, and control system is also a little more complicated than the land rig or jackup rig. And it has, from the BOP which is at the seabed, there is a riser coming to the floating vessel, which can be a drill ship or semi-submersible. So I'll not go much into that. So subsea BOP system is a little different than the jackup system or land system. Then also we have certain equipments like pit volume totalizer. I told you if the pit gain is there, so there is a monitoring system which can tell us that how pits are behaving when we are drilling, and if the pit levels are going up or down, we can notice them and take the necessary right action if there are that that should be the sign of the kick. So these are the equipments we used for detection purposes. Mud gas separator, suppose there is a gas entered the well and we are circulating that gas in a controlled way from the well out. When it comes out, that gas and mud combination passes through this separator where the mud and gas is separated, and gas can be uh, vented to a safe place and mud can be reused. So this is one of the important well control equipment which is used in the well control procedures. This I am just skipping. This flow indicator and pit volume totalizer, I think I have mentioned. So I'm just going fast on it. Okay, so when we get a kick in the well and well has started flowing, the drilling engineer notices that flow is there and the return flow has become more, and indicators are showing that some influx from the formation is entering into the wellbore. So what should be our action? Our action is to shut in the BOP, right? To shut in the BOP, there are two main procedures. One is the hard shutting procedure. Why I am telling? Because some people ask in some interview. Hard shutting procedure is first you stop the rotation. You are rotating and drilling. Stop that. Pick up your Cali, that hexagonal pipe which is used to drill, or top drive. Pick it up. Stop the pump, and then you can watch the well if it is flowing or not, and then you can close the BOP. After closing the BOP, so you should close the BOP as early as possible. Stop rotating, pick up the Cali to the right position, stop the pump, and then close the BOP. After closing the BOP, you can open the side outlet valve, which I showed you in the BOP stack. I have shown you there in the BOP stack. Open the side outlet valve and then you can record the pressures. This is hard shut-in procedure in which BOP is closed in a minimum possible time. But if the formations are very fragile and you are afraid that if you immediately shut in the BOP and it can create some impact, and those fragile formations may fracture under that impact of closing of the BOP, then you can follow a soft shut-in procedure. But most of the companies nowadays follow hard shut-in procedure because it takes minimum time to close the well and minimum kick, because you have closed in a minimum time. So minimum kick invited in the well. So most of the companies go for hard shut-in, but some companies in certain particular formation may go for soft shut-in, in which the procedure will be as I have written down: stop rotating, lift Cali, shut down the pumping. In this, you have to open the side outlet first, then close the BOP, and then finally close the choke. So see the procedure: stop rotating, pick up Cali, space out, shut down the pump. After this, don't close the BOP, open the side outlet, and choke is already open. Close the BOP, and then finally close the choke and record the pressure. This This take a little more time, but if company wants some company policies, some formations not appropriate, like fragile, some companies go for soft shut-in. Mostly 90% of the companies go for hard shut-in. Okay, so what is the well control procedure? First, detect a kick from the detecting system, from your monitors, from your instruments. Detect the kick. Once the kick is detected, immediately close the valve, close the BOP. Then there are two jobs to be done. Once the BOP is closed, you record the pressures, how much pressure you are getting on the drill pipe, how much pressure you are getting in the casing or annulus. Record them. Record what is the depth at that particular time. And then your job will be, there are two jobs you have to do. One is to remove that influx which has come into the well. There are two jobs which a drilling engineer does after closing the BOP. One, the influx which has already come into the well, that need to be taken out. Number two, a right type of mud which will be able to take care of the high pressure which we have encountered, which is called kill mud. That mud is to be transferred into the well. These two jobs we done. First, detecting a kick. Second, closing the well BOP. Number three, circulating out the formation fluid which has come into the well, circulating it out. Number four, pumping in the required mud weight, mud, which is called kill mud, into the well, so that well has now the kill mud which is appropriate for the formation which we have encountered. And then after ensuring that kill mud is in the well and it is of the appropriate weight, you can open the BOP and start drilling further. And well is safe. This is the procedure which a drilling engineer follows when he encounters a kick situation. Before a kick situation occurs, even when a shift driller goes to drilling, he goes to his site and take up the drilling. He takes something called slow circulation rate. Why? Because when kick comes, you cannot kill the well at the rate at which you drill the well. When you drill the well, you may have to use the mud circulating rate very high, because your purpose at that time is to lift the cuttings. But when the kick has come, your job is to take that influx which has come from the formation to the wellbore, that is to be taken out in a controlled way. For that, you don't need to pump that high as for the drilling. So for that, you will be pumping at a slow circulation rate. That killing will be done at a lower rate than the drilling rate. So that is called slow circulation rate. So what the driller or the drilling engineer does when he joins his shift in the morning, he takes a slow circulation rate, which is that, say, at 30 strokes per minute, or 1/3 of the drilling rate. Say drilling rate is 90 strokes per minute. So he will 1/3 of the 90 means around 30. So he will check at 30 strokes of the pump, mud pump per minute, what pressure he is getting on the gauge. So he will record that in the morning when he goes there, so that when the kick comes, this data will be useful. So this is a preliminary data which every driller, when he goes to his shift, will take these readings so that he can record it and use it when the real killing process, if at all encountered, can be useful. So slow circulation rate is recorded, which is the pressure when the pumping rate is 30 strokes per minute, what pressure you are getting on the drill pipe, that pressure is the slow circulation rate will be recorded. Second thing, before you start, you have say lowered 13 3/8 inch lowered intermediate casing, and now you want to start drilling for the final zone, which is the productive zone. So before you start drilling for the productive zone, you should test how much strong your formation is. Why? Because when you will try to circulate the influx which you will get as a cake in the later time, that when you will be circulating, you should ensure that your formation is strong enough to bear those pressures which will come when you rolling the kick. So that is why leak off test is performed well ahead, so that these are preliminary. Slow circulation rate and leak of test, formation strength. These are the preliminaries a drilling engineer does before encountering any difficult situation. And these data help him control the drilling situation in most effective way. Okay, so we have got a kick. We have closed the BOP. Okay, I would like to show you one video before I take this up. Nikhil,
Yes, sir.
I want to show one video which will give them the guideline, and then when I explain to them, it will become very easy. So
Okay,
I
you
am
can see. Sir.
okay.
Welcome to the ADCO Learning from Incidents series. Welcome and blowout prevention. We will be sharing with you some information on well control during drilling, the various systems put in place to control a well and prevent a blowout incident from occurring. We will also review the main reasons behind some of ADCO's well control incidents which were handled successfully. Prior to the preparation of the drilling program, the asset development team submits the final well prognosis to the drilling team. The well prognosis is initiated by the petroleum engineer. The reservoir engineer then makes a planning overview and provides the required formation pressures and temperatures. Then the following data is completed: geodetic data, conceptual data, geological data, reservoir data, geophysical data, and petrophysical data. Once all the data is entered, the well prognosis will be approved by the Reservoir Operations Asset Team Leader and will be published in ADCO system. Let's begin by explaining well control. While drilling, it is essential to perform activities in a safe way, which will prevent uncontrolled flow of formation fluids and gases from the reservoir to the wellbore and surface surroundings. This is called well control. This includes measures, practices, procedures, and equipment.
workover and completion, as well as the installation, repair, maintenance, and operation of surface well control equipment. It also consists of well control barriers, which are divided into two groups, primary and secondary barriers. The primary well control barrier is the fluid column hydrostatic pressure, referred to as well bore pressure, that provides overbalance against the formation pressure. This column must be monitored and maintained during drilling and tripping to prevent formation fluids from entering into the wellbore. During drilling, if the fluid column is not maintained with adequate mud density, making the formation pressure more than the hydrostatic pressure, formation fluids will find a way into the wellbore and a kick will occur. In this case, the well must be secured and killed. There are other cases when a kick can occur. Let's review some of them. While tripping, if there is a failure to keep the hole full of mud to maintain adequate hydrostatic head, then the hydrostatic pressure will be less than the formation pressure, inducing kick. Swabbing while pulling out of a hole too fast can produce a suction effect, resulting in a decrease in the bottom hole pressure, large enough to allow formation fluids to enter the wellbore, creating a kick. When drilling takes place too fast and into depleted reservoirs without proper reinforcement, it can lead to cracking in the walls and thus losing fluids into the formation, inducing a kick. Once a kick is detected, the secondary well control barrier, blowout preventer, BOP, must be activated immediately by the driller to secure and shut the well for killing operations. This is done by closing the BOP using one of the BOP control panels, one situated on the rig floor and the second situated in the Kumi unit. The driller will shut in the blowout preventer to stop the flow of formation fluids out of the wellbore. Then he will activate the alarm and notify ADCO drilling supervisor and rig manager. Meanwhile, at the rig site, the on-scene commander, ADCO drilling supervisor, will notify Abu Dhabi telecom operator and relevant assets control room and raise emergency tier 1, which activates appropriate emergency response teams. Unnecessary crew will be evacuated to the nearest assembly point. The next step will be to monitor the shut-in drill pipe and the shut-in casing pressure gauges. The kick will be circulated out of the wellbore using the driller method first cycle by pumping drilling fluid downstream and getting returns from the annulus through the choke line to the choke manifold, and the pourvoy degasser and toxic gases will be flared. Once the kick is out, the well will be shut in. Then, the well will be killed with weighted mud by circulating the kill fluid until both the drill pipe and casing pressures reach 0. If all of the well control barriers failed, such as human barriers, BOP equipment barriers, and system barriers, and the BOP leaked while circulating the kick out, this could lead to uncontrolled flow of formation fluids and possibly a blowout. A blowout has massive catastrophic consequences, such as injuries and/or fatalities of personnel, release of toxic gases, pollution of the environment, asset damage, and damage of ADCO's image and reputation. ADCO strives to create a safe and incident-free working environment for all. This is why strong well-control integrity assurance systems have been put in place. These include policies, standards, procedures, people competency,
Despite all of this, ADCO has experienced several well-controlled incidents, which have been managed and controlled successfully, preventing a blowout. After sharing with you the primary and secondary well control barriers, we will now share with you some of the main causes behind ADCO's major well control incidents. No implementation of top 3 concept, plan, what if, competent people, incorrect formation pressure and drilling fluid weight. Failure to implement management of change procedure whenever there are changes. Failure to maintain BOP equipment. Learning outcomes from such incidents include: ensure every drilling operation begins with the discussion of the top 3 concept. Always use updated reservoir pressure data for defining drilling fluid weights. Make sure that any change in the drilling plan is governed by an approved management of change process. In case of well control, shut in the well immediately as per ADCO procedures and consult your supervisor. In conclusion, well control incidents must be avoided by all means, as they can lead to blowouts which have catastrophic impacts. At ADCO, we expect from all the well drilling stakeholders to ensure 100% full implementation of ADCO well control integrity assurance systems. It is the responsibility of all managers and supervisors, both in the office and at the rig site, to verify and enforce the full compliance of these systems to avoid catastrophic incidents from happening. With your continuous dedication, compliance to ADCO procedures,
Yeah, Nikhil.
Yes, sir. Yes,
Is
sir, the
the
video completed.
video was clear?
Yes, the video was clear, sir. Now you can start with presentation, sir.
Okay. This video
Okay.
was from ADCO, and it's a very good, one of the best companies in Abu Dhabi, and they have very strict drilling procedures. And you have seen how different departments like geology, from reservoir engineers and geophysicists, and all that data is collected and interpreted, and how a drilling engineer works upon them. And then finally, the drilling team with drilling engineer, supervisors, tool pushers, they together implement that and drill the well with all that information with them, and mud logging and other instrumentations. They are picking the warning signs at different times, and communicating it to driller, drilling engineers, supervisors, so that they can make the right decision, observing those particular measurements and that monitoring. So this is how a team work together.
Excuse me, sir. So
Yeah.
sorry to interrupt. So your mic is, I think, somewhat down, sir.
Okay. Now okay.
Now, okay, sir. Now.
Video, which I worked for ADCO for some time. So this is a good video which has given a revision and how different engineers like geophysicists, geologists, reservoir engineer, and drilling engineers, they work together when they drill exploratory difficult well, and when they're and also the mud loggers and other team people, they are monitoring for any kick indications, and then execution of the BOP and closing of the BOP in the shortest interval, to see to it that a minimum influx is uh, gained. So, so this was a revision of the whole thing. So let's go further with our work. So when we have, now we are at a stage that for some reason, we were drilling a well, our mud hydrostatic efficient to handle the formation pressures, formation kick, formation influx entered the wellbore. It was noticed by the drilling engineer and the mud logger. Well was flowing. Mud return indicators were showing that return is much more than it should be. Pit volumes are gaining. That means some influx is entering the well. Immediately, the pump was the Kelly was rotary stopped. Kelly picked up, and pumps were stopped. It was observed after stopping the pump that well is still flowing. Immediately, the BOP is executed and BOP is shut in. When the BOP is shut in, secondary well control system has come into action, and further influx coming into the well bore is stopped. And now is the time for the calculations and planning work. Well is shut in. BOP, which is primary well control, which was drilling mud, failed because mud weight was not sufficient for the formation pressure. Influx entered the well. Kick has come. BOP executed. Secondary well control in operation. Well is shut. Further influx entry is stopped. The drilling engineer will note down the shut-in drill pipe pressure and the shut-in casing pressure. Drilling engineer will also note down what is the mud weight in the well. He will also record what is the true vertical depth of the well at that particular time. This is the data the drilling engineer will collect, and he will discuss with the drilling supervisor, company man, tool pusher, and other people to make a plan how to kill the well. There are few methods by which well can be killed. One of them is driller method, which is the simplest method well, that is driller method. Second is weight and weight method. In the driller method, there are when a kick has come and BOP is closed, there are two jobs basically which we need to do. One is that influx has come into the wellbore. Now we have to remove this influx is one of the jobs. And second job is that the mud weight was not sufficient. That is why the kick has happened. So one is to take that influx out, and second is to put the right mud weight, which is kill mud weight, into the well. So these two functions are to be performed in any killing method. And while you are performing these two functions, you have to ensure that your bottom of the well bore should always have a pressure more than the formation pressure, so that while doing all these processes, further influx should not enter the hole. So formation bottom hole pressure in the well bore should be always kept more than the formation pressure. So driller method, there will be two cycles. In the first cycle, you will take the influx out, and in the second cycle, you will put the kill mud in the well. This is driller method. Weight and weight method, instead of going for the two cycles like 1 and 2, you will go straight away with the kill mud and pump kill mud, and you will be taking the influx out and pumping the kill mud down in the same circulation. If you do that, that is weight and weight method, and in that there are some calculations. They also call it engineer's method. It involves certain calculations, and that some at certain times that method is useful. Suppose we are drilling a well and our drill bit is choked and we cannot pump, then you cannot apply driller method or weight and weight method. How to control the kick now? At that time, there is another method called volumetric method. You can use that volumetric method. We'll go, if time permits, into what volumetric method is. Suppose we have pulled out of the hole to change the bit, and we have come out of the hole and we are changing the bit. At that time, well is flowing. So you have closed the blind ram, and now there is nothing in the well. How will you control the well? Then you have to use volumetric method. Suppose you are pulling out and you are halfway up and well has started flowing. You cannot use driller method or weight and weight method. You may have to use volumetric method, or you may have to go in a controlled way to the bottom and then use driller method or weight and weight method. So volumetric method can be useful in these circumstances. Then sometimes the formations are such that they can take the influx which has come into the well. When you push it, it can go back into the formation. The formation are conducive for that. Then instead of circulating all the way up and bringing them out, and many times the gas is H2S or some other gases which are coming out of the well, then you have to use volumetric method. Volumetric method means Nikhil. Hello, hello.
Hello, yes, sir, yes, sir, yes, sir.
Yeah, I had a connection problem and I have retained the connection.
Yeah,
Can
no
I
problem,
speak
sir.
now?
Yeah, yes, can. Okay.
Okay, I again apologize for the connection problem and we are back. So these are the four methods which we use, and driller method and wait and wait method are most commonly used. And if some situation or out of the well, drill pipe out of the well, or we are off the bottom, then volumetric can be used. And also when the formations are conducive and they can take that influx back into them, you can pressurize from the top and bullhead the influx back into the formation. This type of bullheading can be done. When I was in Kuwait, when I was working for Kuwait Oil Company, I have done this type of thing, which was very common in their HPHT wells. Those particular wells used to create a lot of pressures at the surface. When the kick comes to the surface, very high pressures used to come. And because the formation was so conducive, bullheading the influx back into the formation was the best idea. And Kuwait Oil Company in those high pressure wells, they were using
Sir,
this.
sir.
Yeah, hello.
Sir, your PPT is not coming, sir.
Okay, now coming.
No, sir.
Hello, PPT coming.
No, sir, no, sir. Just open the share screen option, sir.
Nikhil.
Yes, sir, yes, sir.
Okay, okay. I want now to use the screen whiteboard.
So you can go to share screen and you will find one whiteboard option is there. You can...
I'll do. Okay, okay. 1 minute. 1 minute. Excuse participants. Kindly excuse me for what is happening. We'll sort it out in a very short while. And thank you for your cooperation. I'll just try to enlarge the. Is PPT coming now?
No, sir.
It is not coming.
No, sir, no, sir. Wait, sir. We are texting on your chat box.
Nikhil, PPT coming?
No, sir, no, sir. Sir, same thing you
Nikhil.
can do, sir. Yes, sir. Go to Zoom and you will find the share screen option. From there, you can again start, sir.
Nikhil, is PPT coming now?
Yeah. It's not coming, sir. It's coming, sir.
Yeah, Nikhil, is PPT coming now?
Yeah. It's coming, sir. You can, yeah, it's coming, sir. Fine. You can start, sir.
गुड़िया एक काम करो पासवर्ड दो
Sir, close this one, sir.
Hello.
Yes, sir. Yes, sir.
Hello.
Yes, sir.
Yeah, Nikhil, PPT coming?
Yes, it's coming, sir. You can start, sir.
Okay. So first method is driller's method. It is a two circulation method. Okay. In this, the first step is kick detection. We detected a kick. Okay. We stop the pump, stop rotation, and close the BOP. BOP is closed. Okay. After the BOP is closed, one is that influx is in the well. Our job is to take that influx out. So the cycle, our job will be to take the influx out of the well by circulating. But while doing that, we have to ensure that our bottom hole pressure is always more than formation pressure, and that we will do by manipulation of the choke. That is the trick. So the first cycle is taking the influx which has entered the well to be taken out, and while it is being taken out, we have to ensure that the bottom hole pressure in the well should be more than the formation pressure, so that further kick doesn't come, and that bottom hole pressure is kept more than formation pressure, controlled by controlling the choke. That is first circulation. After the first circulation, then you have to do some calculation. You have to second circulation of the drill, the kill mud in the well, right? But before pumping the kill mud, you should know what is the kill mud. So we observed when we shut in the pump in the driller method, the drilling engineer observed that is psi, and his true vertical depth of the well is 1 feet, and in the well the this formula 12.8 plus 500, which is shut-in drill pipe pressure, divided by 0.052 into TVD, and this formulation he will find the kill mud weight required for controlling the well, for controlling that formation which we have encountered, which was more strong than our mud weight of 12.8 ppg, and that formation is giving us a pressure of 500 psi at the drill pipe, which is filled with 12.8 ppg mud. So this pressure which we are getting on the pipe can be converted into mud weight equivalent, and finally kill mud can be calculated. So now we know what kill mud weight we should have. Say it is 13.7 ppg. Now will be the second cycle of the driller method, in which we will pump the kill mud into the well and displace the whole well with the kill mud. Now kill mud we know is strong enough to handle the formation. So while pumping the kill mud also, we have to ensure that the bottom of the well should at all times should be more than the formation pressure, so that no further influx comes and the kill mud is circulated in the total well. And when kill mud start coming out in the shell shaker, that means our full well is filled with kill mud. Then we can record the pressures again, and at that time we should have zero pressure on the drill pipe, zero pressure on the casing. That means the well is successfully killed and BOP can be opened, and with the new kill mud, which is 13.7, drilling can be resumed. So this is driller's method. In weight and weight method, it is a little one cycle method in which the influx which has entered the well will be taken out and kill mud will be pumped at the same time. While the influx is coming out, kill mud is being pumped into the well, and in one cycle only the well will be killed. This is weight and weight method. Why weight and weight method and why driller method? Suppose we do not have sufficient how a kill mud is prepared by adding more barite into that, more weighing agents into that. Suppose I have 12.8 ppg mud in the tanks and I want to make kill mud. So I will add more weighing agents like barite and increase the mud weight, right? Suppose that barite is not there on the rig at that time, not sufficient barite on the rig. Now what to do? You cannot do weight and weight method because sufficient barite is not there. So at least you can do one thing, you use driller method and take the influx out so that well is clean. And once the well is clean and influx is out, then wait for the barite. And when barite comes, you can do the second cycle and pump the kill mud. So weight and weight driller method can be useful. But when driller method is used in the annulus on the formation, there are more pressures come. So in the weight and weight method, there are less pressures on the formation. So there are less chances of breaking the formation. So in that case, if the formations are very weak and they may fracture, driller method may not be very useful. So you may have to use weight and weight method. So there are times when driller method is more useful and there are times when weight and weight method is useful. And there are times when the drill string is out of the hole or drill string is choked or your pump is not working or any such situation, or you are off bottom, you are neither down nor up, you are somewhere in the middle. In those conditions, you can use volumetric method also. And finally, I'll repeat that if the formations are conducive and they can take the influx back into them, you can create a high pressure at the pumping pressures at the top and push the influx which has come from the formation back into the formation. So I'm not going very much into the details of these methods. Nikhil,
Yes, sir.
should we try whiteboard?
Yes, sir. We can try, sir.
Okay, I'll try. Nikhil, can you help me?
Yes, sir.
Okay, just see if anybody has a question.
Sir, present PPT completed, sir. Slides.
No, I can do some work on the whiteboard and explain the calculations. Okay.
Okay, sir. I'm texting you in chat box.
No, one minute. Is PPT there?
Yeah, PPT is coming, sir.
Okay. So I can show the participants This is a solved example. This is a field data of a well-controlled problem. So if they can see this, they can zoom this and see what type of data is collected by drilling. Nikhil, can you do that? Are you able
Yes,
to do that zooming? And they
yes,
can
we can
see.
zoom some. We can zoom, sir. No
Okay,
problem at all, sir.
right. So this type of well-controlled problems are faced in the actual situations, and this type of data, like hole size and where up till what depth is 95 by 8 inch casing, and what type of drill pipe is there, what is the capacity of the drill pipe, how many heavy weights are used, how many drill collars are used, in the well, and how much is the inner what is the annular capacities and what is the capacities of the drill collar, and all that data is available to the drilling engineer to do his calculations. And also when the well is shut in by closing the BOP, the drilling engineer takes shut in drill pipe pressure. In this particular case he has taken 500 psi, and shutting casing pressure is 700 psi, and he saw that pit gain is 20 barrel. Pit gain 20 barrel means 20 barrel of influx has entered the well. You know, the pit, our pit has gone up by 20 barrel. That means new influx at the bottom has entered by 20 barrels. Correct. So this type of data is collected by the, and also as I told you, circulation, slow circulation rate is 550 at 30 SPM. So in the beginning of the shift, before the kick came, drilling engineer was ready with his slow circulating data, and he has at 30 stroke per minute pumping rate 550 psi. So drilling engineer is ready with all this data to do his calculations, right? So now I'll show you another very important document of a drilling engineer which he uses to kill a well, and that is kill sheet. So this is a specimen kill sheet. Nikhil, are you able to see the kill sheet? Yeah, Nikhil.
Yes, sir. We can see, sir. We can zoom also. No problem, sir.
Very good. So in this kill sheet, there is volumetric data. Like when you are drilling at this particular depth where the bit is, how much is the string volume? From the top in the string, how much volume? How much is open hole volume? How much is cased hole volume? And what are the formation strength data? Which you have taken from the LOT, which I told you that some preliminary data is collected, and what are the LOT and formation strength, what is the fracture gradient of the formation, all that data can be collected on this kill sheet to facilitate the drilling engineer in the killing process. The second part of the kill sheet is this. In this, the drilling engineer will calculate by this particular formula, which is very easy formula, from the different pressures which he has recorded, say 500 and 700 psi, which he has recorded. He has calculated the kill mud weight 13.7. Okay, so he found that 13.7 is the kill mud weight. Now he also found that when he will now say he want to use a weight and weight method. So in the weight and weight method, he will be pumping the kill mud at the same time, and influx will be coming out at the same time. He will be pumping kill mud straight away. He has enough barite, and after shutting in the well, he did all these calculations. He did all the planning, and he told the mud engineer to make the kill mud ready. Kill mud is ready with us, and he can straight away start. And our formations are not very strong, so weight and weight method is a good method. So what he will do is he will slowly start pumping at the kill rate, which is 30 SPM, 30 strokes per minute. he will start pumping the kill mud into the well, and at the same time influx will be coming out of the well, right? So for doing this, he need to follow some procedure. So what procedure he will follow is from this skill sheet. So he will see that his initial circulating pressure is 550 plus 500, 1050. Why it is 1050? Because when the BOP was shut, you got 500 on the drill pipe. That means the formation is stronger than the mud weight by 500 psi, right? So 500 is there on the drill pipe before you start pumping, correct? And in the static condition, you have 500 on the drill pipe already. Now, when you will start the circulation, you know from your as the slow circulating rate, which you have already taken as a preliminary, that when you pump at 30 SPM, pressure should be 550. So now when he will start pumping 500, the kick formation is pushing from the bottom and giving 500 in static condition. That is shut-in drill pipe pressure. Now shut-in drill pipe pressure is already 500, and I want circulation also. So when I want circulation, and I know circulation at 30 SPM, I need 550 PSI. So when under pressure, when the well is under pressure and showing shut-in pressure of 500, at that time, if you want to start pumping the kill mud at 30 SPM, your pressure on the drill pipe should be 500 for the static condition and 550 to pump at 30 SPM. Both together, that will be 1050. So the initially when you will start the pump, you should have on the drill pipe gauge 1050 pressure, 500 for the static formation pressure, which is pushing us, and in the static condition giving shut-in drill pipe. So that 500 static and 550 at 30 SPM for circulation. So static 500, circulation 550, total 1050. So when we start the pump, our job is to control the choke in such a way that on the drill pipe pressure at 30 SPM, there should be 1050 pressure showing. If it is 1050 pressure showing on the drill pipe gauge, by controlling the choke and pumping at 30 SPM, that means you are controlling in the appropriate coordinated way. And if it is not, you should control the choke a little more, so that finally you should achieve on the drill pipe 1050, which is sum of 500 static and 550 circulating. So initial circulating pressure in the kill sheet is 1050. Now I am pumping kill mud into the well. Has reached, that means the drill pipe section of the well is killed, right? In the drill pipe, I have pumping kill mud, and kill mud has gone into the drill pipe and reached the bit at the bottom. That means the drill pipe is now killed, right? And on the drill pipe, which was showing 500 before in static condition, that should not come, because inside the drill pipe now you have kill mud and it can kill the well, right? So the static pressure, shut-in drill pipe pressure 500, which it was showing before, now kill mud is in the drill pipe. So this 500 will become 0. And when you are circulating, at that time when kill mud has reached the bottom and killed this 500 element, you will have only circulating pressure available to you, which is 550, right? This static part will go away because kill mud has come into the drill pipe and it has killed the drill pipe. So 500 is not required. So at that time only circulating, because you are circulating, only circulating aspect is there. So 550 circulating pressure should be there. But that 550 is for the original mud, which is not very heavy mud. Now you have pumped kill mud into the drill pipe, which is a little heavier mud. So for that, it may not be 550, and it may be 550 multiplied by kill mud weight divided by original mud weight, which will be not 550 but 588. Why? Because kill mud is a little more thicker, a little more heavier. So pumping kill mud will be a little more difficult. So the pumping pressure instead of 550 will be 588. Right? So when the kill mud has reached the bed, the static part 500 is gone, and the dynamic part 550 has become 588. Right? So I repeat again. In the beginning, before pumping the kill mud into the well, initial circulating pressure, when kill mud is not in the well, there is a chart below where pipe 500 static plus 550, 1050. Initial circulating pressure 1050. And when kill mud has gone to the bit and killed the drill pipe part, the static 500 is gone. Only dynamic 5 pressure should be there, but that dynamic will be not now 550 because kill mud is heavier. It will be 588. Now, so the job of the drilling engineer is to control the choke and control the choke, because the whole circulating system is going through the choke, and choke can be restricted or not restricted and can be controlled. And by controlling the choke, drill pipe pressure can be maintained. And how we are to maintain is that in the beginning, initial circulating pressure should be 1050, and finally, when the kill mud has reached the bed, it should be 558. That is what we are to achieve by controlling the choke. And there is a chart below, and this falling of the pressure from 1050 in the beginning to 588 in the end of that string volume, this falling can be regulated by this graph, and it can be fallen from 1050 in the beginning to 588 in the end in a controlled way, following the graph as it is shown below. And after the kill mud has crossed the bit, it can follow straight away. That final 588 can be maintained until the killing of the total well. This is the kill sheet, and this is how a drilling engineer executes the killing operation. Nikhil, okay? Nikhil.
Yes, sir.
Okay, so this was the kill sheet, how a drilling engineer uses the kill sheet and controls the well using the choke and controls the initial circulating pressure and the final circulating pressure as per the kill sheet. To the kill sheet they have made, and according to that regulated pressure, he will kill the well. And in this, it will be ensured that no pressure transfer into the well while killing the well. So this is the procedure. Nikhil.
Yes, sir.
Can we go for question answer?
Yeah, sure, sir. Sure, sir.
Okay. Thank you, sir. Thank you, sir, for the wonderful session. So now we would move on to our much anticipated moment from the audience, that is the Q&A session. So I request all the participants to please raise hands, and if you have any questions, we're going to unmute you.
Nikhil.
Participants, please ask your questions if you have any. Sir, we have got some questions. Hello.
Okay.
Okay. Okay, so sir, first question. Sir, as we are killing a well, we are putting a high PPG mud, but if there is a fluid loss in the well or formation damage loss due to the kick came, how can you tackle this situation? And what will be our calculation at that time?
Okay. In the beginning, yeah,
Sir,
Nikhil.
your voice is not audible, sir. Yeah, sir.
Nikhil, I in the primary control there was leak of test. In the leak of test, you will know how much strong your formation is, right? How can expose your formation to, right? And when we are killing the well, pressure that it should not exceed the maximum allowable pressure which our formation suggests. And while killing a well, we should be always monitoring at the choke that our surface pressure should not exceed the maximum allowable surface pressure which our formation strength suggests. So that is taken into account, and by monitoring that surface pressure not to exceed the maximum allowable surface pressure. If that is maintained, you will not create a loss situation.
Okay, thank you, sir. Moving on to next question. Sir, while drilling HPHT wells, what types of problems will you encounter?
In HT well, can lose the mud and settle, right? Particularly temperatures are also very high. So the mud engineering need to ensure that mud should be homogeneous and steady, and a effective mud weight is acting at the bottom. That is one. Second, we are encountering the HPHT means high temperature also. So in high temperature, mud should be compatible with those high temperature and should not distort in the high temperature region, right? That is another thing. Then high pressure, because it is high pressure, a very small volume of gas at high pressure, if it comes into the well, will become a very big kick at the surface. That we need to know, right? And also in HPHT wells, because of the temperature, sometimes the well seems to look like flowing. Like it will look like a well flowing, but it is because of the temperature. And we don't know whether it is because of the temperature or because the actually well is flowing. So we do something called fingerprinting. So we know that when because of the temperature, how much return comes, and we measure that and make that a year mark of that, and make a fingerprinting, and so that we don't confuse with a real kick or a little trickling because of the temperature. So there is a fingerprinting or ear marking done while drilling, so that we don't confuse with that temperature reason for flowing or actual flow, and not be closing BOP all the time. So to facilitate that, something called fingerprinting is done. Nikhil. Yeah,
Thank
Nikhil.
you, sir.
Yeah.
Sir. Okay. Okay. Praveen, can you please unmute yourself and ask your question? Okay, so we are moving to our next question. Sir, what are the tertiary methods available other than the relief well?
Actually, tertiary methods depend upon what is the status of the well. Like in Baghjan now, the wellhead and BOP is removed. For some reason, I don't know why they removed that. There's some repair work was to be done on wellhead, and they removed the wellhead and BOP, and then the well started flowing gas, and then it got fire. Now it is gas flowing and on fire. So now in that condition, they probably have to cap it first. They should try capping, and they first the fire, if the possible, can be extinguished. So they'll first try to extinguish fire, and then with cranes and other things, they can try to put a cap. So that will be their try. If it succeed, that is one thing. And second thing is the relief valve is a very little difficult and time consuming thing. It will take a time to relief well, and then finally pump very heavy mud from the relief well to the existing well and kill. So the first job, as it is here also, and sometimes the BOP will melt with the fire. That fire is so much that BOP will melt and it will get whole thing collapsed and all that. So then they need to cut. They need to cut and shape it. And first there will be cutting, and then there will be capping. So it depends upon what type of situation is there and how to handle that.
Okay, thank you, sir. Okay, we have a question from Jacob. Jacob, can you please unmute yourself? Okay, so moving on to next question. So what will happen if a well has multiple kicks, and how it can be prevented?
Actually, multiple kicks should not be happen. That is the effectiveness of drilling engineer has and his team. And should not allow multiple kicks to come. If detecting at the right time and BOP closed at the right time, multiple kicks will not come. That is one. Second, suppose you are poor in your management and multiple kicks have come, then the important factor is the kick tolerance, that you should see whether multiple kicks are within your kick tolerance or not. If they are not, they are inside the kick tolerance, then you may be able to circulate them out effectively without breaking the formation. And if those multiple kicks are more than the kick tolerance, then there will be danger of fracturing the formation.
Okay, thank you, sir. Next question. Suppose based on offset data, we found that a zone is prone to loss circulation. How can we prevent it from happening in our current well?
Okay, please repeat.
Okay. Sir, based on offset data, we found that a zone is prone to loss circulation. How can we prevent it from happening in our current well?
Sir, are you there?
Hello.
Yes, sir. Yes, sir.
Hello.
Yes, sir.
Hello,
Yes,
sir.
sir. Yes, sir.
Okay, okay. Can you? I actually there was some connection problem. I could not
No
hear the
problem at all,
problem.
sir. Sir,
Sir, should I repeat the question?
Yeah, yeah. Please.
Okay. So based on offset data, we found that a zone is prone to loss circulation. So how can you prevent it from happening in our current well?
Okay, if the zone is prone to loss circulation, like Bombay High, we had all loss circulation predicted from the offset data. There can be loss, and when you drill the well, there will be loss. Almost every well we drilled, there was a loss. So then there are methods like you can pump loss circulation material in the beginning. If that works, very good. If that doesn't work, then you put some. There are some pills nowadays. They have designed with some very nice pills which you can pump, and loss circulation can be handled with those particular pills which can be pumped down, and then they strengthen and gelled up, and that gel up goes to the formation, and then loss can be handled. That is another method we can use. And many times if that also fails in Bombay High, when I was there, we used to pump cement plugs and squeeze cement into the formation, and that cement goes into the sulfide. And then later when you drill back the same hole, that hole then behaves better, and sometime again still doesn't behave better. So that cement plug, we used to pump cement plugs, one cement plug, then second cement plug, and then third cement plug. And but nowadays I heard that mud engineering has advanced, and the pills are quite effective, and those pills can uh, uh, loss occurrence. And also the problem with the loss is that when we drill and there is a total loss, then there is a chance that some other zone may not kick. That is the main issue with the loss, that there may be a loss and some kick also happens, and that kick will be very difficult to be controlled with the loss. Now there are managed pressure drilling methods, mud cap methods, by which you can drill these wells quite easy and not with that great difficulty. So amped feed is a good solution.
Okay, thank you, sir. So next question, why not apply the driller's method immediately after the stabilization of pressure?
Many times the pressures on the formation are more than in the wait and wait method. So if you apply the driller method, that formation will be exposed sometimes. Actually, if the open hole volume is more, if the open hole volume of the well is more, at that time, uh, uh, if the wait and wait method will give a little less pressure to the formation, and you will be more safer. So you cannot go straight like that. So you may have to use a wait and wait method.
Okay, so participants, you have any questions you can ask? Please raise your hands if you have any.
You can ask any question regarding to the topic. I think no questions.
Okay.
Okay, Nikhil, please conclude the session.
Yeah, okay. So thanks to all for your valuable time and cooperation to make the event successful. I, on behalf of the Petroleum Engineers Association, thanking Vipin Bhalla sir for his presence and providing us time for his busy schedule. Thanking him for his informative and valuable presentation. Hope all of you enjoyed this knowledge sharing session. I am thankful to all of your active participation. I extend my big thanks to all my team members for their extensive support. And please kindly fill the feedback form we have provided in the WhatsApp group. And also you can ask question, you can mail on our official mail. We will forward to the sir.
Okay, Nikhil, what I want to say is this is a 5 days course condensed into 2 hours.
Yes, it's from today to 10th of July, sir. If there, just you can see that chat box, so many questions are there, like
okay, Nikhil.
Yes, sir.
So this is for the participants that this is a very shortened
we have got
view,
feedback. Yes, sir. We have got feedback also.
Yeah.
Yes, sir. This is a really very informative session, and the questions we will mail to you also.
Okay, then thank you.
Thank you so much, sir. Yeah, we will provide the PPT on our LinkedIn official page. You can take from there, and soon you will get video on our YouTube channel. You can watch from them there too.
Okay, I thank the petroleum.
Sir, 1 minute, sir. Ritu Parna Tamuli want to ask some questions, sir. Yeah, you can ask Ritu Parna. Just unmute yourself and you can ask. Ritu Parna, you can ask your question. I have.
Hello, thank you, sir. So wonderful session.
Okay. Thank you, sir.
Okay, thank you, and we will have further sessions also. Actually,
Sure,
this is
sir.
a 5 days course, and we have put it down to 2 hours. We may have later some 3 days or something like weekend course like that.
Yes, sir. Sure, sir. We will have, sir.
So, okay, we can leave now.
Sure, sir. We can leave. Okay, thank you to everyone. Just kindly fill the feedback form. It will close at 9 o'clock. Okay, sir. Have a good day, sir. Good night, sir. Yeah, we are closing the meeting.